the number of ways of painting the faces of a cube with 6 different colors. Most important one. Most important one. And it requires the common sense. It requires the common sense. Please see that. The question here, the number of ways of painting the faces of a cube with 6 different colors. How many faces will be there for a cube? 6 faces. Cube contains 6 faces. What is the surface area of each face? Equal. No change at all. Is there any base for the cube? No base. No base. Whatever the face is occupying the floor, that will be the base. So the base can be any face here. Repeat. There is no fixed base here. There are no legs here for the cube to understand this is the base. If you have legs to the cube, then you can say that is a base. But here, there is no base. Any face can be the base. That means any face can be turned to the base, turned as the base. So, by taking 6 colors, if you colored 6 different faces, and if you turn the cube, there are no numbers given here. My dear boys and girls, understand. My dear boys and girls, there are no numbers given here like first phase, second phase, third phase, fourth phase, fifth phase, sixth phase, like that. If the numbers are given, they differ. There is no doubt in that. But here, simply he said it as cube. The numbers are given. Let me say first phase can be painted in 6 different ways, I'll say. Then the second phase can be painted in 5 different ways, I say. Third phase, because the numbers are there to show that this is the first phase, to show that this is the second phase, to show that this is the third phase, like that. But the numbers are not there. And they are all of equal area. Surface area of each face is equal. And hence, that makes no difference in painting 6 colors to 6 different faces of a cube when there are no numbers given to the face, or we can say there is no special recognition to any face. All faces are to be treated same. So the answer is only one here. It can be painted in only one way. That is why I have taken the diagram for you to explain it in a clear manner. Okay, that's what it is. Let us move to the next question. The number of positive integral solutions of ABC is equal to 30. If you take ABC is equal to 30, like if you say ABC is equal to 30. Let me take more space there, because you will understand it in a better way. A, B, C is given to be 30. Now what I do, I'll be prime factorizing 30, my dear boys and girls. As you all know, the prime factorization. What is the prime factorization? Prime factors for this: 2 into 3 into 5 is nothing but 30. Here also, A into B into C. As I said, my dear boys and girls, as I said, I have to fill 3 different boxes. My dear boys and girls, pay your attention here. You have to fill 3 boxes here. 1, 2, 3 boxes here with 3 different digits. That's all. I'll tell you an example, like this is one type of values that can be given away to ABC, isn't it? Just see how this is like this. A can be given away number 2, or B can be and B can be given away number 3, and C can be given away number 5. That means those 3 places can be filled with the 2, 3, 5. That is one of the combinations you have to understand. This is one of the combinations. I gave you the example there. Like that, how many combinations, different combinations will be there to get the product 30 with different values for A, B, C. That's what it is. Very simple. Now, the first place, this is A, related to A here. Related to A here can be filled in how many different ways? Can be filled in how many different ways? There are how many prime numbers are there? How many prime numbers are there? Just check it out. How many prime numbers are there? 3 are there. 2, 3, 5. So this can be filled in 3 different ways, my dear boys and girls. Understand that? What I mean to say by that, I'll make the box still bigger so that you will have clear idea about this. What I mean to say by that, I can fill the first blank place either with 2 or with 3 or with 5. So it can be filled in how many different ways? 3 different ways. Okay. Similarly, this is also can be filled with 2 or 3 or 5. It can also be filled in 3 different ways. And third blank place can also be filled with either 2 or 3 or 5. It is 3 different ways. So what is that to be understood? First operation can be performed in 3 different ways. Second operation can be performed in 3 different ways. Third operation can be performed in 3 different ways. Then all these operations, one after the other or simultaneously, can be performed using the principle of counting in 3 into 3 into 3, which is 27 different ways, my dear boys and girls. So your option is 27 here. Please understand. My dear boys and girls, this is a simple one to understand. And you may be getting a doubt like this. Sir, when you are filling this with 2, how can you use the 2 here? When you are filling this with 3, for example, then how can you use 3 there? Like this it is. We need only the factors in the multiplication here. I'll tell you an example like this. See, to clear that doubt, first blank place you filled with 2. Okay. Second blank place also you filled with 3 ways it can be filled. No, 3 ways it can be filled. Second blank place also filled with 3. This is the value of A now. Okay. And third blank place I filled with 5. That is B. And second blank place with 5. And third blank place none. That is 1. So what is the combination then? You will have 6 into 5 into 1 is one combination. This is what you have to understand. So one blank place can accommodate 1 number or 2 numbers or 3 numbers or no numbers like this. No numbers. No numbers means 1 because it is a multiplication. Similarly, it can also be written like this. 30 into 1 into 1. Okay. Similarly, it can be written in 15 into 2 into 1. Like this, you will have different combinations. And those combinations are nothing but 27, which is the option number B. This is what you have to understand broadly. It is a common sense point you have to understand. Now, let us move on to the next question here. Because I explained you factorial, this problem is very much based on the factorial. Let us understand the meaning of factorial first. N factorial is nothing but 1 into, 2 into, 3 into, 4 into, so on into n is nothing but n factorial. What is the meaning of 5 factorial? 1 into 2 into 3 into 4 into 5. This is the product of n consecutive natural numbers is nothing but n factorial. So let us see here. What is that given? Let us understand first. 2 power n within the brackets 1 into 3 into 5 into so on into 2n minus 3 into 2n minus 1. My dear boys and girls, just observe the factors there. All the alternate factors are given. The 2 odd factors are given. To make it a factorial, you must have consecutive product. Consecutive product, consecutive natural numbers product. But what are the numbers missing in this case? What are the numbers missing in this case? Let me write that more clearly for your better understanding by leaving the space like this. 1 dot 3 dot 5 dot and so on 2n minus 3 dot again last one 2n minus 1 again the last one. I left the space just to make it a factorial. How to make it a factorial? You must have the consecutive natural numbers. So I'm filling them. Just see that. I'm filling the missing factors. Missing factors. What are the missing factors here? 2, 4, 6, and so on. This is 2n minus 2, my dear boys and girls. And this one is 2n. Check it out, please. Check it out. I want to make it a factorial. That is why I supplied missing factors. I supplied missing factors. Now, what all the factors that are missing here, what I did, I have just multiplied and now I'm dividing with it. I'm dividing with it. What are the missing factors there? Just that are written in the green color are 2 into 4. Don't think that this is a decimal. This is into here, please. 2 into 4 into 6 into so on into 2n minus 2 into 2n. Whatever is multiplied, that's what is divided. Okay? Now, let us understand. Let us understand here the factorial form of it. That is 2 power n is very much there. Keep it like that. And my dear boys and girls, understand this is 1 into 2 into 3 into 4 into so on into 2n. That is a product of 2n, first 2n natural numbers. The product of first 2n natural numbers, which is nothing but 2n factorial, my dear boys and girls. Nothing but 2n factorial. Let us now simplify the denominator here because these green numbers are now combined with the factorial like this. Now the denominator numbers, you can clearly see, my dear boys and girls, there is 2 common in every factor. 2, 2, 2, and in the last two factors also you can take out 2, and if you take 2 common, how many 2's will be there? Because these are alternate numbers up to 2n. These are alternate numbers up to 2n. Alternate numbers up to 2n. So half of the terms will be there. Half of 2n will be n. Half of 2n will be n. So how many 2's will be there? n 2's will be there. So you will get 2 common here, 2 common here, 2 common here, and the last term also 2 common there. How many such 2's you get common? N such 2's you get common. So which is nothing but 2 power n. What is that remaining in the brackets? Let me write that. It is 1 into 2 into 3 into so on into the last terms are n minus 1 into n. My dear boys and girls, just check it out. This is 2n getting cancelled now. You see that? You are getting 2n cancelled there. 2 power n, I'm sorry, 2 power n getting cancelled there. And what is that remaining? Just check it out. It is 2n factorial divided by the denominator is n factorial. So this is a problem you have to understand, and your option there is A, 2n factorial by n factorial. My dear boys and girls, you have to understand this problem from top to bottom and as well from bottom to top. That means in both the ways this question can be asked. So if it is asked like this, you have to simplify like this. If this is asked in the question, this is asked in the question, and the question is given in the options, answer is given as question and question is given in the options, then also you must be in a position to understand. So you must be thorough from top to bottom and bottom to top. This is what a problem based on the factorial. Let's